Hello and good afternoon to all of you. I hope all of you are doing well and all of you are in good health. In today's class, we will discuss some of the important page replacement algorithms. To begin with, let us try and understand first in, first out page replacement algorithm. First in, first out page replacement algorithm is the simplest of all the page replacement algorithms, wherein a queue is maintained for all the current pages that are there in the memory. So first in, first out is the simplest of all the page replacement algorithms, where a queue is maintained for all the current pages that are there in the memory. In the queue, the oldest page is placed at the front end and the latest one are placed at the rear end. So the queue that is maintained for all the current pages in the memory will host the older pages in the front end of the queue, and it will host the latest pages in the rear end of the queue. Now there might be a question that why are older pages located towards the front end of the queue and the latest pages located towards the rear end of the queue. This is in order to facilitate easy release and prolonged use of page respectively. So older pages are placed at the front end of the queue for facilitating easy release, whereas latest ones are placed at the rear of the queue in order to facilitate prolonged use. Now whenever page fault happens in case of first in, first out page replacement algorithm, the operating system decides on page replacement. So whenever there is a page fault, the operating system decides on page replacement, that is to bring the page that is requested for from the secondary storage to the main memory. So on page fault, the operating system decides on page replacement. Now how does first in, first out page replacement algorithm works? So it adds the newly requested page at the rear end by removing the oldest page from the front end of the queue. So this is the way how first in, first out algorithm performs its operation. So on page fault, the operating system decides on page replacement. It adds the newly requested page at the rear end by removing the oldest page from the front end of the queue. Now here removal is performed only whenever it's required. So for an example, in situation if the frames are empty, then simply we need to allocate the frames to the pages. Whereas in situation if the frames are completely exhausted, then what we need to do is we need to replace the pages that are there in the frames suitably. So here removal is done only when it's required. Now let us discuss a very important anomaly that is called as Bilady's anomaly. Generally, if we increase the number of frames in the memory, that means if we increase the number of frames in the main memory, the number of page faults should decrease due to obvious reason, because when the number of frames in the main memory increases, then the number of pages that are residing on those frames will also increase. So when the number of pages increases, then the probability of having a required or requested page in the main memory increases. So when there are more number of pages accommodated in the main memory, so there will be greater probability of finding the page that is requested for in the main memory itself. So it reduces page fault. But Bilady's anomaly states that, or it refers to a phenomena where increasing the number of frames in the memory increases the page fault as well. So in certain situations it has been observed that with increase in the number of frames in the memory, there is increase in the number of page faults as well. Now let us try and see in which all allocation schemes page fault increases with increase in the number of frames. Now let us discuss some of the notable advantages and disadvantages of first in, first out page replacement algorithm. So the first advantage is that it's very simple to understand and easy to implement. So it's very simple to understand and easy to implement, and computationally it is very simple. So first in, first out page replacement algorithm is easy to understand and simple to implement, and computationally it is very simple as well. Now the disadvantage, the first disadvantage is that it exhibits very poor performance. Now why does it exhibit very poor performance? As you have observed in case of first in first out page replacement algorithm, there is no criteria set for replacing the pages that are there in the main memory. It is because of the characteristics of first in first out technique the pages are replaced, but other than that we do not have any strict imposition of criteria on replacing a page from the main memory. Now this would definitely result in a very poor performance. So first in first out page replacement algorithm exhibits a very poor performance compared to that of all the other page replacement algorithms. First in first out page replacement algorithm suffers from Bilady's anomaly. So this is one of the algorithm that suffers from Bilady's anomaly, wherein the increase in the number of frames would lead to increase in the number of page fault. As stated previously, implementation does not depend on any factor, right? Okay, so here we do not take into consideration any factor, rather than it simply works on replacement of the oldest page. So here we do not impose any criteria on page replacement, so it exhibits a very poor performance. Now let us try to understand first in first out with the help of a very simple example. Now consider that there are 4 frames and we have a page reference string specified as follows. So the page reference string specifies the sequence in which the pages belonging to the process is referred to during the course of execution. So here we are considering that there are 4 frames and there is a page reference string which represents the pages pertaining to the processes that are referred to at different point in time during the course of execution. Now for simplicity, let P represent the page, H represent the page hit, M represent the page miss, and F1 to F4 are the frames. So for simplicity we are using the notations P, H, M and F in order to represent page, page hit, page miss and frames. Now here we have coined a very important term that is called as page hit and page miss. Now page hit, it refers to a condition where the requested page is found available in the main memory. So page hit refers to a condition when the requested page is found available in the main memory. Likewise, page hit miss refers to a condition that represents or that refers to a situation when the requested page is not found in the main memory. So page hit and page miss refers to the condition of presence or absence of the requested page in the main memory respectively. So page hit, again I'm repeating it, page hit refers to the condition when the requested page is found available in the main memory, and page miss refers to a condition when the requested page is not found available in the main memory. So in this situation we need to bring or load the page from the secondary memory onto the main memory. Now page miss is also referred to as page fault. So page miss and page fault is same. Now here I have created a 2-dimensional representation where you have 4 frames, frame 1, frame 2, frame 3 and frame 4, and we have 3 notations that are, these are page, hit and miss. Now let us consider that the page reference string is processed. That means the pages that are there pertaining to the processes are requested for in sequence. So the first page that is requested for is page number 1. So whenever page 1 is requested, page 1 is not found in the memory or in the main memory. So none of the frames are having page number 1. So we have a page miss. So once we do find that there is a page miss, the page is loaded from the secondary memory onto the main memory and placed in the frame. Now once the page number 1 is placed onto a particular frame. Then we have made a request for page number 0. Since page number 0 is also not available in the memory, so again we'll have a page fault or a page miss. So as it is not found in the memory, again it will be loaded from the secondary memory onto the main memory. Now after that, after page 0, there is a request for page number 2. So since page number 2 is not available in the memory, again there will be a page miss. So now page number 2 will be loaded from the secondary memory and placed to the main memory. Now likewise, there is a request for page number 4 after page number 2. So since page number 4 is not there available in the memory, the page will be loaded from the secondary storage device and it will be placed onto the main memory. So for the initial 4 pages 1, 0, 2, 4, here we do not require replacement because the frames were empty when the allocation started. So when the pages 1, 0, 2, 4 were assigned to the frames were empty, so we did not do any replacement. Now from this particular point onwards, we will find that the frames are completely exhausted. So frames are now currently holding pages. So any page that is to be bought from the secondary memory and is to be placed into the main memory, we need suitable replacement. So now let us see how first in first out algorithm tries to replace the pages that are there currently in the memory to make space for a new page that is requested in the course of process execution. Now here we see that there is a request for page number 8. So whenever there is a request for page number 8, in case of first in first out, the oldest page that is there in the memory will be replaced. So the oldest page that is there in the memory is 1. So 1 is replaced with 8. So this is the way how first in first out algorithm works. Now after that, there is a reference to page number 9. Now page number 9 is not available in the main memory, so it has to be loaded onto the main memory from the secondary memory. So again we have a page miss. So now the oldest page that can be replaced is page number 0. So page number 0 is replaced with page number 9 and it is executed, and then the page will be executed by the processor. Now likewise, after 9 there is a request for page number 5. So since page number 5 is not there, so what we need to do is we need to bring the page from the secondary memory onto the main memory and replace the oldest page. So here the oldest page that we have is page number 2. So 5 will replace page number 2. After page 5 there is a reference for page number 2. So since page number 2 is not there, so again what I need to do, I need to load page number 2 from the secondary memory and place it onto the main memory. So here page number 2 will replace page number 4 because 4 is the oldest page that is there in the set of frames in the main memory. Now after page number 2 there is a request for page number 13. Now since page number 13 is not there, page number 13 has to be bought into either of these frames. So what I'll do is I'll release the oldest page. So the oldest page is page number 8. So page number 8 will be replaced by page number 13. Now likewise, after 13 there is a request for page number 0. So again page number 0 is not there. So now I need to replace the oldest page. So the oldest page is page number 9. So page number 9 is replaced with page number 0. After page number 0 there is a reference for page number 1. So now page number 1 is not there, so I need to replace the oldest page by page number 1. So the oldest page is page number 5. So 5 is replaced with 1. Now after that we have a reference for 11. Now 11 is not already present in the memory, so I need to perform replacement. So I need to replace the oldest page. So here the oldest page is page number 2. So page number 2 is being replaced by page number 11. Now after that we have a reference for page number 4. Now page number 4 is not there in the memory, so it has to replace the oldest page. So if you see, the oldest page is page number 13. So page number 13 is being replaced by page number 4. Now likewise you have a page reference for page number 9. Now page number 9 is not there in the memory, so again it has to be loaded and it has to replace the oldest page. So the oldest page here is page number 0. Now after 9 there is a reference for page number 11. Now page number 11 is already there in the memory, so it is in frame number 4. So since page number 11 is there in page number 4, there is a page hit. So whenever there is a page hit, no replacement is required. So since the requested page is available in the memory, so here it is at frame number 4, so we refer to this particular condition as page hit. So whenever page hit happens, no replacement is done. Now after reference to page number 11, there is a reference to page number 12. Now page number 12 is not there in the memory, so the oldest page that is there in the memory will be replaced by page number 12. So if you see, the oldest page is page number 1, so page number 1 will be replaced by page number 12. Now after 12 there is a reference for page number 9. Now page number 9, if you see, it's already available in the memory in frame number 2. So here there is a page hit. So whenever there is a page hit, there won't be any replacement taking place. Now after reference to page number 9, there is a reference to page number 8. Now page number 8 is not available in the main memory, so what it has to do, it has to replace the oldest page. So here the oldest page is page number 11, so page number 11 will be replaced with page number 8. Now after 8 there is a page reference to page number 5. So page number 5 is not available in the memory, so what I need to do is I need to replace the oldest page. So here the oldest page that we have is page number 4, so page number 4 is replaced by page number 5. Now after that we have a reference to page number 4. So page number 4 is not available in the memory, so what I need to do is I need to replace the oldest page. So the oldest page here, now what we have is we have 9, so 9 is being replaced by page number 4. Then we have a page request for 8. So since 8 is already available in the memory, there is a page hit. So if page hit happens, no replacement takes place. Now after 8 there is a reference to page number 3. So page number 3 is not available in the memory. So now what I need to do is I need to replace the oldest page. So if you see, the oldest page is page number 12. After 3 there is a request for page number 1. So page number 1 is not available in the memory, so page number 1 has to be loaded from the secondary memory and it has to be placed onto the main memory. So page number 8, being the oldest page, will be replaced by page number 1. And eventually there is a request for page number 0. So page number 0 is not available in the memory, so we'll find the oldest page. The oldest page is page number 5, so page number 5 will be replaced by page number 0. So this is the way how first in first out algorithm works. So here what do? Is we replace the oldest page whenever page miss occurs. So whenever there is a page miss or whenever there is a page fault, the oldest page will be replaced by the latest one. Now if it is getting difficult for you to understand, just remember that we will perform removal of the pages from the frames in sequence. So first I'll remove it from F1, then I'll remove it from F2, then I'll remove it from F3, and eventually I'll remove it from F4. And this particular cycle repeats until unless all the pages are brought onto the main memory. So this is a very simplified way of solving first in first out algorithm. So what I'll do, I'll follow the sequence of removal in the order: frame 1, frame 2, frame 3, frame 4. Again I'll repeat it: frame 1, frame 2, frame 3, frame 4. So that is the sequence in which the replacement will be done in case of first in first out if there is a page hit. So this is the way how first in first out algorithm performs its operation. Now here we have very simple statistics being evaluated. So we have number of page hits. So there are 3 page hits. There are 21 page misses. So there are 3 page hits and 21 page misses. So page hit ratio is estimated. So it is estimated as 3 by 24 because total number of instances are 24. So it will be 3 by 24 into 100. So that comes to around 12.5. And page miss ratio, which is 21 by 24 into 100, that comes to around 87.5. So 12.5 plus 87.5 equates to 100. So this is the way how the ratios of hit and miss are expressed in case of first in, first out. So in today's class, what we have learned about is we have learned about the way how the first in, first out replacement algorithm works. We have learned about why first in, first out page replacement algorithm exhibits very poor performance. We have learned about what is Bilady's anomaly. We have learned about some of the notable advantages and disadvantages of first in, first out page replacement algorithm, and then we try to discuss first in, first out page replacement algorithm with the help of a very simple example where we took in 4 frames and we took in a page reference string, and then we try to perform replacement based on the requirement of page fault, and eventually we calculated the number of page hits, we calculate the number of page faults or page misses, and then using that we determine the page hit ratio and the page miss ratio. In the subsequent classes we will be discussing the rest of the page replacement algorithms. Till then, thank you very much and have a very good day.